Welcome back to Sleepy Orbits. Maybe the rain has finally settled in against the window. Maybe you're the last one awake in the house, phone face down at last, staring at a ceiling that has no answers. Either way, you're in the right place. And tonight, I want to start with something that sounds like the opening of a mystery novel, because it is one. Out past Neptune, past Pluto, out where sunlight grows so weak it can barely cast a shadow, astronomers have found a group of small frozen worlds whose orbits all lean the same way, tilted together, aligned like compass needles agreeing on a direction, like fish all turning at once in dark water. And when the discoverers calculated the odds of that happening by chance, the number that came back was 0.007 of 1%. Something out there is herding them. That is the plainest way to say it, and it is not a fringe claim. It comes from some of the most respected planetary astronomers alive, published in the mainstream journals, argued over at every major conference for the last decade. The simplest explanation for what we see is a planet, a big one, 5 times the mass of Earth or more, hiding in the dark at 500 times Earth's distance from the Sun, so far away that it may take 20,000 years to complete a single orbit. A major planet in our own solar system that no human being has ever seen. Here's the thing most people don't realize. We have mapped galaxies 10 billion light years away. We have photographed a black hole's shadow in another galaxy, weighed stars on the far side of the Milky Way, and counted ripples in space itself. And the map of our own backyard is not finished. The outer solar system, our own home address, is one of the least explored places in all of astronomy. And the evidence says there may be an entire world out there, circling our own sun, still waiting to be found. Tonight, the edge of the solar system is going to feel a lot closer and a lot stranger than it did this morning. And there has never been a better night to tell this story, because as you're falling asleep right now, a brand new telescope in the mountains of Chile has just switched on the searchlight. One thing before we begin: if you fall asleep partway through, good. That's the point. In the morning, tell me in the comments the last thing you remember hearing. And if you make it to the end, tell me which part of the hunt for Planet 9 stayed with you and what you'd like us to explore next. If these nights help you rest, a like or a subscribe helps this channel more than you'd realize. Now, let's begin. Hold that image of the leaning worlds a moment longer, because it deserves it. Picture the solar system from above, the familiar circles of the planets, and then, far beyond them, a scattering of tiny icy bodies on long, stretched, lonely orbits, each one a slow ellipse, taking thousands of years. There is no reason for those orbits to agree about anything. They should point every direction at random, like straws dropped on a floor. Instead, the most distant ones bunch together, their closest approaches to the sun crowd into the same quarter of the sky. Their orbital planes tilt off the flat of the solar system in the same way. 6 objects in the original discovery, all swinging through space like they had compared notes. 0.007 of 1%. Those were the published odds of coincidence. Think about that for a second. If you ran the solar system 10,000 times, you would expect an arrangement like this to happen by luck in fewer than one of them. And here is what makes the mystery irresistible rather than merely strange. We have seen this exact situation before. Once before, in all of history, astronomers stared at objects moving in ways they shouldn't, suspected an unseen world was responsible, did the mathematics, pointed a telescope, and found a planet sitting exactly where the numbers said it would be. It is the single greatest prediction ever made in science. It happened in 1846, and it is the reason every astronomer alive takes tonight's mystery seriously. Because the last time the solar system moved like something invisible was pulling on it. Something invisible was. But before we meet the astronomers and their equations, we need to spend a little time in the dark itself. Because the first honest question anyone asks about this story is the obvious one. How could we possibly lose a planet? How, in an age of space telescopes that photograph the infant universe, could something 5 times the mass of Earth be hiding in our own solar system? The answer is one of the most underappreciated facts in astronomy, and once you feel it, the whole mystery changes shape. The outer solar system is dark in a way the human mind has no reference for. Every planet you have ever seen in the night sky, you have seen by reflected sunlight. Venus blazes because it sits close to the fire. Jupiter shines because it is enormous. But sunlight weakens fast as it spreads, following the same law as any light. Double the distance, and a world receives 1/4 the light. Push a world 10 times farther out, and it receives 1/100th. Neptune, the most distant known major planet, orbits about 30 times farther from the Sun than Earth does, nearly 3 billion miles out, and at that distance, high noon is 900 times dimmer than a summer day here. And yet Neptune is close by the standards of tonight's story. The hypothetical planet we are hunting would sit around 500 times Earth's distance from the Sun. Out there, the Sun delivers 250,000 times less light than it delivers to your window. And for a telescope on Earth, the situation is doubly cruel, and this is the detail that explains everything. We see a distant planet by light that must first travel all the way out from the Sun, growing weaker the whole way, then bounce off the planet, then travel all the way back to us, growing weaker the whole way home. The dimming multiplies. The mathematics of it stacks against you with a vengeance. Take a planet at Neptune's distance and push it 20 times farther out, and it does not become 20 times harder to see, or even 400 times harder. It becomes roughly 160,000 times fainter. That is the wall the outer solar system hides behind. It is why we can photograph a galaxy of 100 billion blazing stars 10 billion light years away, while a cold, quiet world in our own yard, a world 1,000 times closer than the nearest star, can drift through century after century of human astronomy without leaving a single confirmed trace. Galaxies make their own light. Planets only borrow it, and out past Neptune, there is almost nothing left to borrow. So hold on to this, because it reframes the entire night. The absence of a photograph means almost nothing out there. In the outer solar system, not seen and not there are very different statements. Astronomers estimate the survey coverage of the deep outer solar system remains thin even now. The dark past Neptune is not a scanned and emptied room. It is an unopened archive, bigger than everything we know put together. The region between Neptune and the supposed orbit of Planet 9 could hold thousands of unknown worlds the size of cities, hundreds the size of countries, and, just possibly, one the size of several Earths. And our sky surveys until very recently would have missed nearly all of them. Which is why when astronomers want to find something in that dark, they usually don't reach for a camera at all. They reach for the one messenger that cannot be dimmed, blocked, or hidden. Gravity. Every object with mass tugs on every other, everywhere, always, no matter how dark. You cannot photograph a hidden world, but you can catch its fingerprints on the things you can see. And the story of how humanity learned that trick, learned to see with gravity instead of light, is one of the finest stories science has ever produced. It begins with a planet misbehaving. In 1781, a musician turned astronomer named William Herschel, scanning the sky from his back garden in England with a homemade telescope, stumbled across a slow-moving point of light that turned out to be a planet. He wasn't looking for it. Nobody was looking for it. Nobody in recorded history had imagined the solar system held planets beyond Saturn, and then one evening, it simply did. They called it Uranus, and it doubled the size of the known solar system overnight, and almost immediately Uranus began causing trouble. Astronomers do not just find planets, they predict them forward. Using Newton's laws, they compute where a planet will be next month, next year, next century, and Uranus refused to cooperate. Decade after decade, it drifted off its predicted path. Only slightly, a wobble measured in arc seconds, a deviation smaller than the width of a human hair held at arm's length. But Newton's laws do not have moods. If a planet is off its path, something is pulling it. By the 1840s, the anomaly had become one of the most famous problems in science, and a young French mathematician named Urbain Le Verrier decided to solve it in the boldest way imaginable. He would assume the pull came from an unknown planet farther out, and he would compute from the wobble alone exactly where that planet had to be. No telescope, no searching, just months of hand calculation, page after page, inverting Newton's gravity to read the position of a world nobody had ever seen. In the summer of 1846, Le Verrier announced his answer to the French Academy, a specific point in the constellation Aquarius. The observatories of France, incredibly, didn't bother to look. So Le Verrier mailed his prediction to a young astronomer in Berlin named Johann Galler. The letter arrived on the 23rd of September 1846, Galilei opened the dome that very night, pointed the telescope at Leverrier's coordinates, and within an hour, there it was. A new planet, sitting less than 1 degree from the predicted spot. Less than 1 degree. Leverrier had aimed across 3 billion miles of darkness using nothing but arithmetic and missed by less than the width of 2 full moons. They named the planet Neptune. A colleague later said Leverrier had discovered a planet with the point of his pen. There is a heartbreak hidden inside that triumph, by the way, and it belongs to a young Englishman named John Couch Adams. Working alone in Cambridge, Adams had attacked the same problem at the same time and arrived at nearly the same answer, by some accounts earlier than Leverrier did. He tried repeatedly to get the attention of England's Astronomer Royal, George Airy, and was met with delays, doubts, and a bureaucrat's request that he first answer a technical question which the shy young man never quite got around to doing. England, which held the calculation in its hands, never mounted a serious search in time. When Neptune was found from Berlin on French mathematics, the British scientific establishment realized with horror what it had let slip through its fingers, and the two nations fought bitterly for decades over credit. History's verdict has softened into a shared discovery, but the lesson of Adams cuts in one direction, and every planet hunter since has taken it personally. In this business, being right is not enough. Somebody has to point the telescope. I want you to feel what that moment meant, because tonight's entire mystery rests on it. A human being sitting at a desk read the gravity of the solar system so precisely that an invisible world was forced out of hiding. Gravity had become a telescope, the dark had lost its immunity, and every astronomer since has known, deep in their bones, that when the outer solar system wobbles, you take it seriously. Sometimes the wobble is a new world waving at you through the mathematics, but the same history carries a warning taped to the trophy, and honesty requires we read that too. Because Leverrier himself, the man with the magic pen, spent the rest of his life trying to repeat the trick, and the sequel is one of the strangest cautionary tales in science. Flush with the triumph of Neptune, he turned his mathematics on the opposite end of the solar system, on little Mercury, the innermost planet. And Mercury, it turned out, was also misbehaving. Its elliptical orbit slowly pivots around the Sun over the centuries, like the petals of a drawn flower being rotated, and when Leverrier computed how fast that pivot should be, accounting for the tug of every known planet, Mercury came up stubbornly wrong. The discrepancy was tiny, 43 seconds of arc per century. A leftover drift so small it takes 3,000 years to add up to a single degree. But Leverrier had built his fame on exactly this kind of tiny leftover. He knew what it meant. It meant something unseen was pulling. And so, in 1859, with total confidence, he announced the cause: an undiscovered planet, or swarm of planets, circling inside Mercury's orbit, hidden forever in the blinding glare beside the Sun. The world believed him instantly. Why wouldn't it? He was the man who had found Neptune with arithmetic, The new planet was named before it was found. They called it Vulcan, after the Roman god of the forge, a world of fire hugging the furnace of the sun. Within months, a French country doctor and amateur astronomer named Lescarbot reported he had watched a small dark dot cross the face of the sun. Leverrier personally interrogated him, came away convinced, and Vulcan entered the textbooks. And then began half a century of embarrassment. Vulcan was seen, and then not seen. Astronomers rushed to total solar eclipses, the only moments the sun's glare relents, and scanned the darkened sky beside it. Some swore they glimpsed it. Others, with better instruments, found nothing at all. Sightings were announced and retracted, announced and retracted, for decades. Leverrier died in 1877, still believing in his second planet. The wobble, meanwhile, refused to go away. Mercury kept drifting, 43 arc-seconds per century, decade after decade, a real anomaly, as real as the one Uranus had shown, and no planet was ever there. The answer, when it finally came, arrived from a direction no astronomer had thought to look. In 1915, Albert Einstein completed his general theory of relativity, the discovery that gravity is not a force reaching across space, but a curvature of space itself. And near a mass as large as the sun, that curvature does something Newton's laws never imagined. It slowly pivots the orbits of anything nearby. Einstein computed the size of the effect for Mercury, 43 seconds of arc per century, exactly, to the decimal. He later said the discovery gave him heart palpitations, and no wonder. The wobble had been real all along, the mathematics had been sound all along, and the hidden thing pulling on Mercury was not a planet. It was a missing piece of physics itself. Vulcan had never existed. The anomaly was the universe politely informing humanity that Newton was not the final word. So now the ledger of gravity, our perfect witness, reads like this, and it is worth saying slowly, because tonight's whole mystery will be judged by it. When the solar system wobbles, history offers three verdicts. Sometimes it is a new world, waiting exactly where the pen points, as Neptune was. Sometimes it is an error in our own books, a mismeasured mass, a biased count, a ghost of our own making. And sometimes, most wonderfully and most rarely, it is the third thing, a signal that the laws themselves are due for an upgrade. All three have happened. All three began identically, with something in the sky refusing to move as commanded. And tucked away in the modern journals, sure enough, there are a few physicists arguing that the clustering at the solar system's edge might be that third kind of clue, a whisper of modified gravity rather than a planet. They are a small minority. But after Vulcan, no one laughs them out of the room. The wobble always tells the truth. The hard part, the part that can take 70 years, is learning what question it is answering. And the outer solar system's next wobble was already on its way. It would take a century to arrive. It would come not as a drift in a known planet, but as a scatter of impossible new worlds. And the story of its discovery begins with the strangest planet hunt of the 20th century. After Neptune's triumph, astronomers naturally tried the trick again. By the late 1800s, some believed Uranus and Neptune were still wandering slightly off their predicted paths, tiny residual wobbles that refused to close. If one hidden planet had explained the first anomaly, perhaps another hidden planet explained the rest. The wealthy Boston astronomer Percival Lowell became obsessed with the idea. He called the unseen world Planet X, built a private observatory in the high desert of Arizona largely to find it, and spent the last years of his life computing and searching, sweeping the sky along the paths his mathematics suggested. He died in 1916 with nothing. But his observatory kept the hunt alive, and in 1930 it hired a 24-year-old farm boy from Kansas named Clyde Tombaugh, a self-taught amateur who had ground his own telescope mirrors from salvaged machine parts, and it gave him the tedious job nobody wanted. Photograph the sky along the predicted track, 2 plates of the same star field taken nights apart, then compare them, star by star, hundreds of thousands of stars, looking for the one dot that moved. On the 18th of February 1930, after 10 months of that, Tombaugh found his moving dot. The announcement went around the world. Planet X was real. They named it Pluto, and for a moment the pen had done it again. Gravity had summoned a second world out of the dark on command. Except, quietly, over the following decades, the story fell apart in the most instructive way possible. Pluto, as telescopes improved, kept shrinking. First it was judged smaller than Earth, then smaller than the Moon. In the end, Pluto weighed in at about 1/500th the mass of Earth, a lovely, complicated little ice world, but thousands of times too small to tug Neptune or Uranus even slightly. Whatever Lowell's mathematics had been tracking, it could not have been Pluto. Tombaugh had found a real world by pure heroic thoroughness, sitting almost exactly where a wrong calculation had told him to look. It remains one of the great coincidences in the history of science, and Tombaugh, to his everlasting credit, did not stop. Convinced there might be more to find, he kept blinking plates for 13 more years, ultimately checking tens of millions of star images across most of the sky. 7,000 hours at the eyepiece of his comparator, a labor almost impossible to imagine now. He found asteroids, comets, star clusters, and no more planets. That marathon matters to tonight's story more than it seems, because it drew one of the first great fences around the problem. Whatever else hides in the sun's family, Tombaugh proved by brute force that nothing bright remains. Anything still out there would have to be far dimmer, far smaller, or far, far more distant than anything his plates could catch. The dark kept its secrets, but it had been forced for the first time to state its terms. So what had been pulling on Uranus and Neptune? Here is the ending almost nobody knows. In 1989, the Voyager 2 spacecraft flew past Neptune. skimming its cloud tops, and in doing so it finally measured Neptune's mass with real precision. The new number was slightly different from the one astronomers had been using for a century, and when a scientist named Miles Standish reran the old calculations with the corrected mass, the famous leftover wobbles simply evaporated. There had never been a Planet X anomaly at all. There had only been a slightly wrong number for Neptune, echoing through everyone's equations for 100 years. The ghost that launched 1,000 sky searches, the ghost that built an observatory in Arizona, the ghost that put Pluto on the map, was a bookkeeping error. I'm telling you this story for a reason, and it isn't to be discouraging. It's because tonight's mystery deserves an audience that knows the whole ledger. Gravity found Neptune flawlessly with the point of a pen. Gravity summoned Vulcan out of physics we hadn't learned yet, and gravity conjured Planet X out of a rounding error, kept the whole world believing for decades, and sealed the illusion by handing Tombor a real little world on the wrong coordinates. Every astronomer working on this today knows all three stories by heart, tells them to their students, and lies awake wondering which one they are living in. Keep all three in your hands as we go. That tension is the honest shape of everything that follows. And what follows began, as these things often do, with one impossible object showing up where nothing should exist. In November of 2003, a team of astronomers led by Mike Brown at Caltech, along with Chad Trujillo and David Rabinowitz, was running a survey of the outer solar system, hunting the faint and slow. They found plenty of ordinary distant worlds. Then, one night, their software flagged something that was neither. It was moving so slowly against the stars that it had to be extraordinarily far away, roughly 90 times Earth's distance from the Sun, well beyond every known planet and comet swarm. They named it Sedna, after the Inuit goddess of the sea, who lives at the bottom of the frozen Arctic Ocean, and the more they learned about it, the less sense it made. Sedna is a world about 1,000 kilometers across, frozen and utterly alone. And it is one of the reddest objects in the entire solar system, redder than Mars. Its surface is thought to be an ancient rind of ices varnished by eons of radiation into dark, crimson organic residues, the slow chemistry of cosmic rays working on methane ice for 4 billion undisturbed years. A deep red world, the color of embers drifting through permanent night. Its orbit is a shock. At its closest, it approaches the Sun to about 76 times Earth's distance, more than twice as far out as Neptune. At its farthest, it drifts beyond 900 times Earth's distance. One circuit takes roughly 11,400 years. The last time Sedna was where it is now in its orbit, human beings had not yet invented writing. When it completes this lap, everything you have ever known will be older than the pyramids are today. A fair question might be forming in the back of your mind, and it deserves an answer before we go on. We have only known Sedna exists since 2003. Barely 20 years. How can anyone claim to know the shape of an orbit that takes 11,000 years, from a sliver that small. 20 years out of 11,000 is like judging the whole circle of a clock face from watching the hour hand for 10 seconds. And the answer is one of the oldest and most beautiful tricks in astronomy, invented, fittingly, the last time our species found a new kind of world. In January of 1801, an Italian astronomer named Giuseppe Piazzi spotted the first asteroid, Ceres, tracked it for a few precious weeks, and then lost it, helplessly, as it drifted into the glare of the sun. The world's astronomers despaired of ever finding it again. A few weeks of positions seemed hopelessly too little to predict where it would emerge. A 24-year-old German mathematician named Carl Friedrich Gauss disagreed. Working for months, inventing new mathematics as he went, mathematics the sciences still use daily, he showed that even a short arc of watched motion contains, hidden inside it, the whole orbit, the way a small piece of a circle implies the entire circle, because gravity permits only certain curves and no others. Gauss computed where the lost world would reappear. Astronomers pointed their telescopes there in December, and Ceres was waiting, almost exactly on the predicted spot. The method has been refined for 2 centuries since, and it is how a 20-year arc of Sedna, measured with modern precision against the background stars, locks down an 11,000-year ellipse with confidence. An orbit is not a path we must watch being walked. It is a sentence gravity has already finished writing, and a good mathematician can read the whole sentence from a few of its words. And Sedna has one more gift for our era, a piece of timing so perfect it feels scripted. Sedna is falling toward us right now. It has been falling our way for centuries, sliding down the long inward arc of its orbit, and it will round the corner, its once in an orbit closest approach to the Sun, in the summer of 2076. Feel the scale of that appointment. The last time Sedna made this turn, the Ice Age was barely over, and humanity's largest settlement was a cluster of mud brick huts. The next time, 12,000 years from now, no one can say what will be listening. But this time, this one time, there is a civilization here with telescopes, and children alive tonight will be in their 50s when it happens. Mission designers have already sketched the probes that could ride out to meet it, and the arithmetic is unforgiving. To catch Sedna near its closest approach, a spacecraft would need to leave Earth by sometime in the 2040s. A world discovered 20 years ago is offering us a rendezvous our species gets exactly one chance to keep. But the shocking part is not the size of the orbit. It is that the orbit cannot be made, not by anything we know of. Every other stretched, lonely orbit in the solar system got that way through an encounter, a close pass with a giant planet that slingshotted the object outward. Those orbits keep the fingerprint of the encounter. They swing back at their closest point to the scene of the crime, near the planet that threw them. Sedna never comes anywhere near Neptune. Its closest approach to the Sun is still more than 2 billion miles beyond Neptune's orbit. Neptune cannot have thrown it. Nothing on the map can have thrown it. Sedna is like a car found parked on the summit of a mountain with no road, no tracks, and no fuel spent. The parking job itself is proof that something we've never seen was once there or is still there to do the parking. Mike Brown himself put it simply: Sedna shouldn't be there, and something had to put it there. For a decade, Sedna stood alone, a single anomaly, easy to file away as a freak. Then, in March of 2014, Chad Trujillo and Scott Shepard announced a second one, a smaller world, catalogued as 2012 VP113, with a closest approach even farther out than Sedna's, about 80 times Earth's distance. 2 impossible parking jobs. And when Trujillo and Shepard laid the known distant orbits side by side, they noticed something in the geometry, a similarity in how the orbits were angled, and wrote, almost in passing, that the pattern could be the signature of an unseen giant planet. That one quiet sentence buried in a discovery paper was the spark. Because 2 of the sharpest dynamicists in the field read it, decided the idea was probably wrong, and set out to kill it properly. Their names were Konstantin Batygin and Mike Brown, and their attempted debunking is how the modern Planet 9 hypothesis was born. Understand who these 2 men are, because the pairing matters. Mike Brown is the most successful planet hunter alive. He led the discovery of Sedna and of Eris, the distant world so nearly Pluto's twin that its discovery in 2005 forced astronomy to finally define the word planet, a definition Pluto famously failed. Brown is, by his own cheerful admission, the man who killed Pluto. His autobiography is literally titled How I Killed Pluto and Why It Had It Coming. Konstantin Batygin is one of the finest orbital dynamicists of his generation, the kind of physicist who can read a set of orbits the way a doctor reads an X-ray. In 2014, they shared a hallway at Caltech, and when Trujillo and Shepard's suggestion of a hidden planet appeared, the 2 of them began meeting regularly with a shared goal, and that goal, in the beginning, was to disprove it. Both of them have said so publicly. They considered the idea of a large, undiscovered planet an extraordinary claim, the kind that is almost always wrong, and they expected a few months of careful analysis would bury it politely. The first thing they did was clean the data. Many known distant objects have orbits still touched by Neptune, contaminated evidence, orbits Neptune can nudge and reshape. Batygin and Brown threw those out and kept only the pristine cases, the objects whose orbits never come near any known planet, the ones whose stories cannot have been written by anything on the map. 6 objects survived the cut: Sedna and 2012 VP113 among them. And when they plotted those 6 orbits together, the 2 men went very quiet. The orbits did not scatter randomly the way independent histories should. All 6 long ellipses swung out into the dark in the same direction, tilted off the plane of the solar system at nearly the same angle. Batygin has described the 6 orbits as looking like flower petals arranged around a center, or 6 hands on 6 clocks, all frozen near the same hour. In physical space, the pattern jumps off the page. These objects, separated by billions of miles with orbital periods of thousands of years, were moving in formation. They calculated the probability that 6 independent orbits would agree like that by pure luck. The number came back at about 7/1000ths of 1%, roughly 1 chance in 14,000. That number should be handled with care, and we will handle it with care later. But first, feel its size. If you were dealt a poker hand that improbable, you would not congratulate yourself. You would check the deck. Tugging and Brown checked the deck for over a year. They tried explaining the pattern with the known planets. It failed. They tried explaining it with the gravity of the distant comet cloud. It failed. They tried a scenario where the objects heard each other and found the outer solar system doesn't hold enough material to do it. One by one, the mundane explanations died, and the explanation that refused to die was the one they had set out to kill. A single unseen planet, massive and far away, on a stretched orbit of its own pointing in the opposite direction from the clustered 6, could shepherd exactly this pattern. Not roughly, exactly. In January 2016, they published in the Astronomical Journal under the deliberately dry title, "Evidence for a Distant Giant Planet in the Solar System." The press called it Planet 9 within hours, and Brown, the man who had killed the 9th planet a decade earlier, found himself announcing the case for its replacement. He has joked about it many times since that fate has a sense of humor, that having subtracted one planet from the solar system, he now owed it another. But in interviews from those first days, you can hear something else underneath the jokes, something closer to awe. These were 2 skeptics who had walked into the problem to end it, and the problem had converted them. So let's meet the suspect, as the mathematics sketches it. Planet 9, in the current best estimates, refined over a decade of further work, is a world of roughly 4 to 5 times the mass of Earth, possibly a little more. Its orbit likely averages around 500 times the Earth-Sun distance, swinging perhaps as close as 300 and as far as 700 or 800. A single year on Planet 9, one loop around the Sun, would take somewhere in the neighborhood of 10 to 20,000 Earth years. Since the last time this world was at its current position in its orbit, our species has invented agriculture, cities, writing, mathematics, telescopes, and the internet, and it has completed perhaps one lap. And here is a detail that makes the hypothesis more beautiful rather than less. A world of 5 Earth masses would belong to the most common class of planet in the galaxy, and the one class our solar system mysteriously lacks. When astronomers survey other stars, they find that planets between the size of Earth and the size of Neptune, the super-Earths and mini-Neptunes, are everywhere. They are the galaxy's default product, the standard model, the planet the universe apparently loves to make, and our solar system skips that size entirely. We jump straight from Earth at 1 Earth mass to Uranus and Neptune at 15 and 17. The most ordinary planet in the galaxy is the one thing missing from our shelf. If Planet 9 is real, the gap fills itself. Our solar system would turn out to own a copy of the galaxy's favorite planet after all. We just filed it in the dark. The hypothesis also started paying rent almost immediately, and in science, that is the tell worth watching. A good theory doesn't just explain the clue it was invented for, it starts explaining clues nobody asked it to explain. The outer solar system holds a small population of bizarre objects on orbits tipped nearly perpendicular to everything else, worlds orbiting at right angles to the solar system's flat plane and a few even orbiting backward. Nobody had any mechanism for those. Batygin and Brown simulations of Planet 9 produced them automatically, unprompted, as a side effect. And when they went looking, the predicted objects were already sitting in the catalogues, discovered years earlier and filed away as unexplainable. The hypothesis even offered an answer to a much older riddle. The Sun itself is tilted. The entire plane of the planets is tipped about 6 degrees relative to the Sun's own spin, a lean that has bothered astronomers for a century. A massive planet on a distant inclined orbit, tugging at the whole system for billions of years, could have slowly wrenched the planetary plane into exactly that kind of lean. One invisible world and half a dozen separate mysteries fold up and put themselves away. That is either the signature of a real planet or the most seductive coincidence since Pluto turned up on Lowell's wrong coordinates, and the only way to know which is to find it or prove it isn't there. Which brings us to the obvious question, the one you've been patiently holding since the beginning. If the mathematics is this good, why hasn't anyone just looked where it points and seen the thing? Stay with me a moment on how the herding actually works, because the mechanism is gentler and stranger than the word planet suggests. Planet 9, if it exists, never comes anywhere near the worlds it shepherds. This is not a cowboy riding through the flock. Across billions of miles, its gravity at any given moment is barely a whisper. But orbits are patient things, and whispers repeated for 4 billion years become commands. Each time one of the distant objects loops through its long ellipse, the far-off planet's pull tilts and turns that ellipse by an amount almost too small to measure. The trick is that the nudges do not average away. Because the planet follows its own slow, stretched orbit, pointed in the opposite direction from the flock, its influence arrives with a rhythm, and orbit by orbit, millennium by millennium, the ellipses of the smaller bodies are steered into the only configuration where the nudges stop fighting them. Think of pushing a child on a swing. Each push is nothing, a touch, but arrive with the right rhythm again and again, and the swing rises as high as you please. The clustered orbits we observe are the swings that found the rhythm. In the simulations, objects that drift out of the pattern get herded slowly back, or thrown out of the solar system entirely. And after billions of years, what remains is exactly what we see in the sky. Survivors, aligned, leaning together, keeping formation around a partner they have never once approached. When Batygin runs the mathematics forward, the flock and the planet trade angular momentum in a slow, eternal circulation like two dancers who never touch, connected only by the music. We found the flock first. The dance is the evidence. The partner is the prediction. And while the optical telescopes have struggled, the search has still accomplished something enormous that rarely makes headlines. It has fenced in what the hidden thing is allowed to be. This is how astronomy actually advances on a problem like this, not with one eureka, but by shrinking the space where the answer can hide. In 2014, an astronomer named Kevin Luhman published the results of a search using WISE, a space telescope that had scanned the entire sky in infrared light. The wavelength where big planets betray their own inner heat, no matter how little sunlight they catch. The result was a magnificent double negative. There is no Saturn-sized planet anywhere within 10,000 times the Earth-Sun distance. There is no Jupiter-sized planet within 26,000. Those numbers reach a quarter of the way to the nearest star. The age-old nightmare version of this story, the Death Star companion, the giant dark twin of the Sun, cyclically raining comets on Earth. An idea that was seriously entertained for decades under the name Nemesis is dead. The sky has been searched, and nothing that large is out there. What survives the fences is precisely the suspect the orbits describe. Something too small to glow brightly in the infrared, too dim to catch in reflected light. 5 or so Earth masses, hundreds of times Earth's distance. The searches that found nothing did not weaken the case. They sharpened the wanted poster. We are no longer asking whether a large, dark companion of any kind lurks near the Sun. We are asking about one specific, modest, cold world in one shrinking strip of sky, and everything bigger, brighter, or closer has already been ruled out. There is something quietly moving about that, I think. 3 generations of astronomers, most of whom never met, have each crossed off part of the darkness. A survey here rules out giants. A survey there empties half the search zone. A retired satellite's archive, dusted off decades later, trims the possibilities again. None of them found the planet. All of them found where the planet isn't, and where it isn't is how you learn where it must be, if it is anywhere at all. The map of the outer dark is being filled in the way an old chart of the ocean was, voyage by voyage, blank by blank, until whatever still hides has one last blank left to hide in. Tonight, that last blank is a strip of crowded sky near the plane of the Milky Way, a region a few times the size of the constellation Orion. Either there is a world in it, or there is a lesson in it. Astronomy is about to collect one or the other, and while the theorists argued over the mathematics, the discoverers kept doing what discoverers do. They kept adding sheep to the flock. To appreciate what they have found, you have to appreciate how young this entire branch of astronomy is, because the census of the outer solar system is not some venerable old ledger. It barely existed within living memory. As recently as the early 1990s, the solar system's official map ended, for all practical purposes, at Pluto. Textbooks printed the year your parents were born showed 9 planets, and then nothing. An edge, a void. A few theorists, Gerard Kuiper's name among them, had speculated for decades that a belt of icy debris ought to circle out beyond Neptune, leftovers from the solar system's construction, too dim for the telescopes of the day. But nobody had ever seen a single piece of it, and plenty of astronomers doubted it was there. Two people changed that: David Jewett and Jane Lu. Beginning in the late 1980s, they set out to answer a question Jewett phrased with perfect simplicity: is the outer solar system really empty, or does it just look empty? Night after night, on the telescopes of Mauna Kea, they photographed patches of sky and searched them for anything that crept. For 5 years, they found nothing. 5 years. Imagine keeping a search alive for 5 years on faith and stubbornness, colleagues politely wondering aloud if you're wasting your career. And then, on the 30th of August 1992, a faint dot in their images moved at exactly the crawling pace of something billions of miles past Neptune. They had found the first citizen of the Kuiper Belt, catalogued as 1992 QB1. Within a few years, dozens more followed, then hundreds, then thousands. An entire third zone of the solar system, a ring of icy worlds vaster in extent than everything inside it, snapped into existence on the map in a single decade. Pluto turned out not to be a lonely oddball at the edge of nothing. It was simply the brightest member of an enormous frozen crowd, which is exactly why, 14 years later, it lost its planethood. The solar system did not shrink when Pluto was demoted. It had grown so much that Pluto's old title stopped making sense. I linger on this because it answers the question skeptical listeners are quietly asking right now. How plausible is it, really, that big things remain unfound out there? And the answer is that within the lifetime of most people hearing my voice, the largest structure in the solar system was unfound. The Kuiper Belt, thousands of worlds, was a rumor until 1992. Discovery at the solar system's edge is not some closed chapter from the age of Tombor. It is current events. And the census since then reads like a bedtime story in itself, because the hunters of the far dark have a tradition of unserious names for their serious discoveries. In 2018, Scott Shepard's team announced a small world found in October, with the letters TG in its catalogue number, and nicknamed it the Goblin. The Goblin never comes closer to the Sun than 65 times Earth's distance, another car parked on another roadless mountain, and, notably, its long orbit leans with the flock, exactly as the Planet 9 hypothesis predicts. The same team later found a world they nicknamed Farut. At the time, the most distant object ever observed in the solar system, and then promptly beat their own record and, with a shrug of nomenclatural genius, called the new champion Far, Far Out. Far, Far Out was spotted at 132 times Earth's distance from the Sun, more than 4 times as far as Neptune. There is also a world called Leleakuhonua, given a Hawaiian name that evokes a bird flying so high it touches the heavens, whose orbit swings even wider than Sedna's. goblins and faraway birds joining Sedna the sea goddess in the far dark. Each new find is a data point. Some strengthen the clustering. The newest one, ammonite, as we'll see, complicates it. But every single one of them, whatever it says about Planet 9, says the same thing about the neighborhood. The outer solar system is inhabited richly by things we only just became able to see. The census that started with one impossible world in 2003 now reads like the opening pages of a very long book, and the pages are turning faster every year. People have looked. Some of the largest telescopes on Earth have spent years of nights looking, and the story of why they keep coming up empty is a lesson in just how good the universe is at hiding things in plain sight. Start with the brightness problem, which you already understand from earlier tonight. At 500 times Earth's distance, reflected sunlight has been diluted on the way out and diluted again on the way back, and what survives is almost nothing. If Planet 9 is currently near the far end of its orbit, and the simulations suggest it probably is, since objects spend most of their time in the slow outer arc of a stretched orbit, the planet would shine at roughly magnitude 25. Let me translate that number. The faintest star your eye can see on a perfect dark night is magnitude 6. Magnitude 25 is about 40 million times fainter than that. Pluto, when Tombaugh found it after 10 months of eye-straining labor, was several hundred times brighter than what we're hunting now. Only a handful of telescopes on Earth can even register an object that faint, and to do it they must stare at one small patch of sky, gathering light, while the sky drifts and the atmosphere trembles. Then there is the speed problem, which is really a patience problem. Nothing at that distance moves not usefully. A search for a new world works by catching motion, the one dot that shifts against the stars. Pluto gave Tombaugh a shift he could catch across a few nights. Planet 9, crawling through a 20,000-year orbit, drifts across the sky so slowly that between one night and the next, it barely moves at all. You need images separated by long stretches, exquisitely aligned, and software able to recognize the same faint speck in both. Every step is possible. Every step is brutal. Brown and Bataillon have not been waiting politely for someone else to do it either. For years they have carried their prediction to the Subaru telescope on the summit of Mauna Kea, one of the only instruments on Earth with an eye both wide enough and deep enough for this hunt, and they have swept the search zone season after season as weather and telescope committees ration the mountain to them a handful of nights at a time. Clouds have eaten whole years of the campaign, and behind their patience sits a possibility that everyone in the field acknowledges, half in hope and half in dread. The planet may already be in the archives. It may have been photographed years ago, a faint dot on some crowded frame, taken for another purpose entirely, recorded and never recognized. It has happened before, to the most famous eyes in the history of science. In the winter of 1612, Galileo Galilei, observing Jupiter through his little telescope, recorded a dim point of light nearby and noted it as a star. It was Neptune. The planet sat in his notebooks, seen and unrecognized, for 234 years while astronomy grew up around it. Somewhere on a server tonight, the ninth planet may already be a speck in a file, patiently waiting for its galley. And then there is the cruelest twist, the one that feels almost personal. The mathematics of the clustering points toward a search zone, the stretch of sky where the planet most likely hides. And that zone runs almost directly through the plane of the Milky Way. The one strip of sky out of the entire celestial sphere that is packed edge to edge with the dense star fields of our own galaxy's disk. Searching for a magnitude 25 speck, there is not looking for a needle in a haystack. It is looking for one particular grain of hay in the haystack, while the haystack glitters with 100 million brighter needles. Some searchers have had to discard great swaths of their own images because the star fields were simply too crowded to process. If you wanted to hide a planet deliberately, maliciously, you could not choose a better place in the sky to put it. One of the hunters has joked that if Planet 9 turns out to be real, its location will feel like the universe's idea of a prank. You might also wonder why the hidden planet doesn't simply betray itself the way Neptune did, by tugging visibly on the worlds we know. The answer is distance, and it is also, wonderfully, another way to hunt. At 500 times Earth's distance, Planet 9's pull on Saturn or Jupiter is fantastically feeble, far too small to produce a wobble anyone could have noticed in centuries past. But we no longer measure the planets the way past centuries did. For 13 years, the Cassini spacecraft orbited Saturn, and its radio link home functioned as a ruler, fixing Saturn's position to within meters across nearly 1 billion miles. Teams of researchers have combed that exquisite record for the faint fingerprint of a distant fifth giant, and while they haven't found a definitive signal, they have done something almost as useful. They have ruled out large sections of Planet 9's possible orbit, sky, the planet cannot currently occupy without having left marks Cassini would have caught. Another fence, another shrinking of the dark. Even our robot emissaries sent to study the worlds we can see have been quietly deputized into the search for the one we can't. The hunt has produced false dawns, and the most tantalizing one is very recent. 2 old space telescopes, an infrared satellite called IRAS that mapped the sky in 1983, and a Japanese successor called Akari that mapped it again 23 years later, both left behind full sky archives of heat sources. A hidden planet too cold and dark to reflect visible light might still glow faintly in the infrared, warmed by its own slowly leaking interior heat. So in 2025, a team led by the astronomer Terry Long Fan went hunting through both archives for a single trick. A faint heat source present in the 1980s map at one spot, gone from the 2000s map, with a matching source appearing nearby, exactly as if one slow object had crept across the sky in the decades between. Out of hundreds of millions of sources, one pair survived every check. One candidate with roughly the right motion and roughly the right glow, and if it is what it appears to be, it would have to be at least Neptune's mass. The paper made headlines around the world, and then Mike Brown, of all people, the man with the most to gain, looked at the candidate's implied orbit and publicly threw cold water on it. The orbit doesn't fit, he pointed out. An object there, moving like that, would be tilted so differently from the clustered six that it could not be the planet doing the herding. It might be a background galaxy flickering, it might be noise, it might even be some entirely different unknown world, which would be its own astonishment. But it does not look like his Planet 9, and he said so within days. Hold on to that moment because it tells you something important about this field. The people hunting this planet keep shooting down their own best leads. That is what real science looks like at 3 in the morning. And honesty requires the other side of the ledger too. So let me give you the skeptic's case in full, because it is serious, and it might be right. The entire argument rests on those clustered orbits, and clustering has a mundane possible cause: bias in where we've looked. Telescopes do not survey the sky evenly. They dodge the moon, chase good weather, favor certain seasons and certain declinations. If your discoveries all come from surveys that watched particular slices of sky, then of course the orbits you find may share a geometry, the geometry of your own attention. It's the drunkard and the streetlight. The keys are always found under the lamp, because that's where anyone looks. One major survey, designed with carefully tracked pointing, ran the numbers on its own distant discoveries and found them consistent with a uniform, unclustered outer solar system. Other analyses, pooling everything, still find the clustering strong. The two camps have been politely at war in the journals for years, and the honest summary tonight is that the evidence leans, but does not prove. In 2025, the picture complicated itself further when astronomers announced a new Sedna-like world nicknamed Ammonite, whose orbit points in a direction that doesn't join the choir. One voice singing off-key doesn't silence a choir, and simulations suggest Ammonite's orbit may still be compatible with some versions of the hypothesis. But its discoverers were blunt that it weakens the simplest story. The clustering that launched a decade of searching now has its first prominent exception, and everyone in the field felt the temperature drop a little when it was announced. So that is where the mystery stands, poised on a knife's edge that history has sharpened from both sides. It could be Neptune again, a real world waiting at the end of the mathematics, ready to make this the century's greatest astronomical headline. It could be Planet X again, a phantom conjured by subtle errors in how we've counted, destined to dissolve the moment the data improves. Both endings have happened before. Both camps contain brilliant people. And what makes tonight different from every other night in this 180-year story is that for the first time the argument has an expiration date. But before we come to the machine that will settle it, let's allow ourselves the stranger corridors of this mystery, because A 5-Earth mass planet is actually the tamest thing the evidence permits. There are 2 other possibilities, both published in serious journals, and both are the kind of idea that rearranges the furniture in your head. The first possibility is that our solar system contains an adopted child. Think about where a planet like this could have come from, because that question turns out to be nearly as hard as finding it. Planets form from a disk of gas and dust around a young star, and out at 500 times Earth's distance, that disk was almost certainly too thin and too slow to build anything the size of 5 Earths. The materials weren't there. The time wasn't there. So if Planet 9 formed with the rest of our family, it most likely formed in close, among the giants, and was then thrown outward, hurled by a gravitational tussle with young Jupiter or Saturn in the solar system's violent first chapters, and somehow braked and stranded on its long, dark orbit before it could escape entirely. That story can work. But there is another story that works just as well, and it is far stranger. The sun was not born alone. Stars form in litters in dense clusters of hundreds or thousands of siblings packed close together, and in that crowded nursery, stars regularly slid past one another closely enough to raid each other's outskirts. Simulations show that a wandering starless planet, or a planet loosely held by a passing sibling star, could have been captured, quietly handed from one star to another during a close pass, and left behind on exactly the kind of wide, tilted, eccentric orbit the mathematics of Planet 9 describes. If that is what happened, then circling our sun right now is a world that formed around another star 4.5 billion years ago, kidnapped or adopted before the Earth's crust had cooled, carrying alien chemistry from a family we will never meet. The first exoplanet humanity ever visits might be parked in our own driveway. The second possibility is the one that sounds like science fiction, and is not. In 2019, 2 physicists, Jakob Scholz and James Unwin, published a paper with a title that made the entire field look up from its coffee. What if Planet 9 is a primordial black hole? Here is the reasoning, and notice that every step is sober. The clustering evidence measures only one thing about the hidden object: its gravity, its mass. It says 5 Earth masses, or thereabouts. It says absolutely nothing about what the mass is made of. Everyone pictures a planet because planets are what solar systems contain. But cosmology has long predicted that the infant universe, in its first violent second, may have crushed small pockets of itself directly into black holes, primordial black holes, born not from dying stars but from the Big Bang itself, and some models predict them in exactly this mass range, wandering the galaxy in enormous numbers. If one such object drifted past our young solar system, the Sun could have captured it precisely as easily as a planet by the same mechanism onto the same kind of orbit. Gravity is gravity. The mathematics cannot tell the difference. And here is the detail that will stay with you as you drift off. A black hole of 5 Earth masses would be about the size of a grapefruit. I need you to sit with that for a moment. All the pull we've been describing all night, the herding of Sedna's cousins, the tilting of entire orbital planes, the slow 6-degree wrenching of the sun's own spin, all of it could be coming from an object you could hold in your 2 cupped hands. A sphere of pure darkness, roughly the size of a grapefruit, denser than anything else in creation, silently circling our sun for 4 billion years, at a distance where no telescope pointed with any purpose until the last few decades. It would explain every orbit. It would explain perfectly why every optical search has found nothing, why the infrared archives are ambiguous, why the world's largest cameras stare at the right patch of sky and see only stars. You cannot photograph a grapefruit at 46 billion miles. Even the authors call it a long shot, and the boring explanation, a planet, remains far more likely. But the paper survived peer review because no one could show it was wrong, and it comes with a testable signature. Matter falling onto such a black hole would occasionally flash faint, brief glints of annihilating dark matter or infalling comet dust, and astronomers have worked out that the coming generation of sky surveys could actually catch those flashes if they exist. Which means the strangest sentence in tonight's story is technically true. Humanity is currently conducting a search that could discover a black hole inside our own solar system. Whatever it is, planet, adopted exoplanet, or grapefruit of collapsed space-time, I want to take you out there now. We've spent the night reading its fingerprints from a distance. Before the story ends, you should feel the place itself. So settle deeper into the pillow and come with me on the long ride out, because no journey in the solar system says more about where we live than the one that leaves it behind. We depart past Mars quickly through the asteroid belt and the realm of the giants, past Jupiter at 5 times Earth's distance from the Sun, Saturn at 10, Uranus at 19, Neptune at 30. This is the entire solar system of the textbooks, every world ever visited by our machines, and on tonight's map, it is the front porch. Past Neptune, we cross the Kuiper Belt, Pluto's neighborhood, the ring of frozen leftovers stretching to about 50 times Earth's distance, where the New Horizons probe, the fastest thing we ever launched at the outer dark, arrived after 9.5 years of flight. Beyond 50, the belt thins and fails, and the true outer dark begins. Here is Sedna's country, 90 times Earth's distance and climbing. The sun behind us has collapsed into a brilliant point, a star among stars, though still painfully bright, to look at directly, and the temperature of anything drifting here has fallen to within a few dozen degrees of absolute zero. New Horizons, at its tremendous speed, would need well over a century to reach the middle of Sedna's orbit. We keep going, 150 times Earth's distance, 200. The spacing of things out here defeats every metaphor. We pass, on average, nothing, 300. If the planet's orbit brings it this close, this is its warm season, its perihelion summer, and nothing about the darkness around us would tell you so. 400, 500, and somewhere out here in the statistical heart of the search zone, we arrive. 500 astronomical units from home, 46 billion miles. Light from the sun, which reached Earth in 8 minutes, has traveled almost 3 full days to get here. Turn around and look back the way we came. The sun from here is a star, the brightest star in the sky by far, a diamond point of almost painful intensity. But a star, a thing among the other things sitting in the dark like any other. It casts about as much light on this place as a full moon casts on a winter field back home. Think of that. Noon here forever is a moonlit night on Earth. If you held up your hand, you would see it, pale and silver blue, lit by a sun too far away to feel. Every planet, every ocean, every person and empire and memory of our species is huddled around that one cold point of light, packed so close to it that from here the whole inhabited solar system hides behind its glare. You could cover all of human history with your thumb. And here is the detail I'd like you to carry towards sleep. The strangest one of all. Look up, out here, away from the sun. The sky is your sky. Orion stands exactly where you left him. The Big Dipper, the Southern Cross, every pattern your ancestors named, all of them utterly unchanged. Because even this staggering journey, 500 times farther than home, is nothing against the gulf between the stars. The nearest star to the sun is still 500 times farther away than everything we just crossed. From the loneliest world in the sun's family, the universe looks the same as it does from your bedroom window. Only one thing in the whole sky has changed. Our star has stepped back into the crowd. It has stopped being the sun, the fire that owns the daytime, and becomes simply a star among the stars, the brightest one. But one of them, and if you didn't know exactly where to look, you could lose track of which point of light is home. That, more than any number I've given you tonight, is the true size of the solar system. And gliding through that permanent moonlight, if the mathematics is right, is the planet. Probably an ice giant in miniature, a smaller cousin of Neptune wrapped in hydrogen and helium over a mantle of exotic ices 5 times the heft of Earth. Its cloud tops, if it has them, would be among the coldest places in the known solar system, worn down toward absolute zero, stirred perhaps by a faint interior warmth left over from its formation, wherever that was. No day and night to speak of, only the long slide of a year that outlasts civilizations. And it may well have moons. Worlds of its size usually do, and serious papers have worked through what companions would mean for the hunt, because moons, strangely, would make the dark planet easier to catch. A moon raising tides in its parent, flexing it, would warm the planet's interior by friction, and that warmth would leak out as a faint infrared glow, brighter than the planet has any right to be, the kind of signature a heat-seeking survey could snag. Somewhere out here there may be not just a hidden planet, but a hidden family, a dim king with dimmer attendants circling one another in the moonlight of a sun that cannot warm them. If they exist, they have kept each other company for 4 billion years, entirely unwitnessed. If it has rings, they have never once caught enough sunlight for anyone to see them glitter. It has been out here doing this since before there was an Earth to name it, and it will be out here doing this long after. The most patient thing in the sun's family, keeping the oldest secret in the largest dark. And would you believe that even here we are nowhere near the edge? It's true, and it is the last scale shock of the night. 500 times Earth's distance sounds like the rim of everything, and it is not even the beginning of the rim. Beyond Planet 9's whole orbit lies the Oort cloud, the sun's vast spherical halo of dormant comets, trillions of them, stretching outward 1,000 times farther still, out to perhaps a light year or more, nearly halfway to the next star. The sun's gravity holds that entire territory faithfully out to distances where its light is just another star's glimmer. Even Planet 9, the most distant world we can seriously argue about, would be parked in the front half of the property. The comets that occasionally fall past Earth, growing their long, ghostly tails, are messengers from that farther country, the only pieces of it we have ever examined. Our maps run out. The sun's holdings don't. When astronomers say the solar system is mostly unexplored, this is what they mean. Not a gap in the records, but an ocean we have never once sailed, wrapped around everything we know. And the reason tonight's story is different from every telling of this story for the last decade is that the dark is finally about to end. Before we come to the machine that will decide all this, spend a moment with the question that makes this hunt feel different from any other in modern astronomy. What would it actually mean to find it? Not as an abstraction, concretely. What happens? The week a confirmed 9th planet appears in the data. The first thing that happens is that every diagram of the solar system on Earth becomes wrong. Every classroom poster, every museum mobile, every textbook printed in the last century, obsolete in a single press conference. Children alive right now would remember learning the solar system twice, the way their great-great-grandparents' generation once did. Because here is the thing people forget: no living person has experienced this. The last time a true major planet was added to the Sun's family was Neptune in 1846. Pluto's 1930 debut was, we now know, a lovely misfiling, which means the discovery of Planet 9 would be the first genuine planet discovery in most of 2 centuries, and the first ever made in the age of photography, of television, of the internet. Neptune was announced by letters between observatories. This one would be announced to 8 billion people before breakfast. Then it would need a name. And this, quietly, would be one of the most remarkable moments in the history of our species, because it has never once been done this way. Mercury, Venus, Mars, Jupiter, Saturn, carried their names out of Roman antiquity, named by cultures long gone. Uranus was named amid squabbles by astronomers of one country or another. Neptune was named essentially by Leverrier and his colleagues. But a planet discovered now would be named under the procedures of the International Astronomical Union, with input from a connected world, the first major planet in the 4.5 billion year history of the solar system to be named by all of humanity at once, deliberately, together, knowing what it was doing. Whatever name is chosen, mythological tradition suggests a god of the underworld, of the dark and the deep and the cold, and there will be years of glorious argument about it. There are worse things for our species to argue about. For the scientists, the prize is bigger still, and it loops back to that strange gap we discovered earlier tonight. The galaxy's most common kind of planet, the super-Earth, the world between Earth and Neptune in size, is the one kind our solar system was thought not to own. Everything we know about that entire class of planet, the most numerous class of worlds in the universe, comes from squinting at faint dips in the light of stars trillions of miles away. We have never seen one, not up close, not even badly. If Planet 9 is real, the most common planet in the galaxy has a specimen parked within reach of our machines. And every question we have about such worlds, their atmospheres, their interiors, their moons, their weather, could eventually be answered with a camera instead of a statistical model. Astronomers would spend the following decades doing to Planet 9 what they spent the last ones doing to Pluto, and the reward would echo through the study of every planetary system in the sky. Could we actually go? Eventually. Honestly, not soon, and the numbers are humbling in a way that fits everything else tonight. New Horizons, our fastest deep space probe, needed 9.5 years to reach Pluto at 33 times Earth's distance. Planet 9 orbits perhaps 15 times farther still. At New Horizons pace, the cruise would run well beyond a century, a mission handed down through generations of flight controllers like a cathedral handed down through generations of masons. Engineers have sketched faster ways, probes that dive close past the sun and use its gravity and a blast of thrust at the bottom of the dive to sling themselves outward at unprecedented speed. Nuclear stages, ultralight sails pushed by lasers. With aggressive technology, studies suggest the trip might compress to 40 or 50 years. Launch such a mission in the 2040s, and the first close-up photograph of the 9th planet arrives around the time today's newborns retire. That is not a reason for sadness, by the way. There is something right about it. A world that took 2 centuries to find at the far edge of the family should cost a lifetime to visit. The solar system is reminding us what kind of neighborhood it really is. And if the searches come up empty, if the next few years pass and the strip of sky yields nothing, then in its quieter way, the answer is almost as profound, because the clustering still has to be explained. If deep, uniform surveys show the alignment was never real, an artifact of where our telescopes happen to look, then astronomy will have learned in the most public way possible, a lesson about bias that will improve every survey that comes after, and the outer solar system will stand revealed as stranger than we thought in a different way. A place that manufactures Sednas by some road we haven't imagined. And if the clustering survives but the planet is proven absent, then we are left staring at the third door, the Vulcan door, the possibility that the far edge of the sun's domain is whispering something about gravity itself. No outcome of this hunt is boring. That is the beautiful trap of it. The solar system has arranged things so that we win something either way, and the only losing move, the only one, is not looking. Which brings us, at last, to the mountain in Chile. High in the foothills of the Chilean Andes, on a peak called Cerro Pachón, where the air is thin and dry and the nights are among the darkest left on Earth, a new machine has just opened its eye. It is called the Vera C. Rubin Observatory, named for the astronomer whose work revealed dark matter, a woman who spent her career proving that the universe is mostly made of things we cannot see. There is a certain poetry in what her namesake has been built to do. The Rubin Observatory is not a telescope in the way you're picturing. Ordinary great telescopes are keyhole instruments, enormous light buckets aimed at one tiny patch of sky at a time, studying one thing deeply. Rubin is the opposite, a floodlight in reverse. Its mirror spans 8.4 meters, among the largest on Earth, but its genius is its camera, the largest digital camera ever constructed by our species, 3,200 megapixels, the size of a small car, so sharp that a single one of its images would take 400 ultra-high definition screens to display, and it does not linger. It sweeps. Every clear night, Rubin photographs enormous swaths of the heavens, returning to each patch again and again, so that every few nights it has re-photographed the entire visible southern sky, deeper in a single pass than almost anything before it, and then again and again, night after night, for 10 years. Astronomers describe the result as a decade-long movie of the universe. Anything that moves, anything that flashes, anything that changes, gets caught. It is the perfect machine for finding things that drift slowly through crowded star fields. It is, in other words, the machine this entire 2-century story has been waiting for, the answer to Tombaw's blinking plates, scaled up 1,000,000-fold and automated. The numbers coming off the mountain barely fit in the mind. Around 20 terabytes of sky every night. Up to 10 million alerts every night, each one a something-changed flag raised automatically by the software, each checked by machines against everything ever seen at that spot. Tombaugh compared 2 photographic plates at a time by eye, clicking a lever back and forth for months. Rubin does the equivalent of his entire 10-month search many times over before breakfast, every single morning for 10 years. And here is why I said at the very start of tonight that there has never been a better night to tell this story. The Rubin Observatory captured its first test images of the cosmos in the middle of 2025, and the astronomy world gasped at them. Millions of galaxies in single frames, whole swarms of new asteroids discovered in hours. And then, on the 30th of June, 2026, days ago, as I speak these words to you, the observatory formally began the legacy survey of space and time, the full 10-year sweep. The movie has started rolling. Right now, tonight, while you are lying there listening to me, if the sky over Chile is clear, that camera is drinking in the southern heavens, frame after enormous frame, and somewhere in those frames, if it exists, Planet 9 is a faint, unremarkable speck among a billion others photographed, recorded, waiting in the data for the software to notice that between one visit and the next, it moved. The people who have spent their careers on this are saying so out loud, with the giddiness of people who have waited a very long time. Scott Shepard, co-discoverer of the clustering itself, estimates that if the planet is real, Rubin has a 70 to 80% chance of simply finding it, and finding it soon, likely within the survey's first year or two, if it sits in the favored region. Mike Brown has narrowed the hiding zone to a fraction of its original size, and calls this the endgame. Konstantin Batygin frames it more simply than anyone. The hypothesis is finally properly falsifiable. Rubin will either deliver the planet or deliver the thousands of new distant objects whose orbits will show, once and for all, whether the clustering was ever real. Because that is the other blade of this machine. Even if it never photographs the planet itself, Rubin is expected to multiply the census of the distant solar system many times over, from dozens of these faint, far wanderers to thousands. The flock is about to be counted properly for the first time. If the alignment is real, it will stand out with overwhelming statistics, and the planet's position will be triangulated finer and finer even before it is seen. If the alignment was a mirage of biased looking, it will dissolve in front of the whole world, and the ghost will finally be laid to rest beside Vulcan and Planet X. Either way, the strangest thing about tonight is this. The 200-year story you have been listening to, a story that has moved at the pace of centuries, of 11,000-year orbits and lifetimes spent on single calculations, has suddenly acquired a countdown. The people who study this expect an answer not in some vague someday, but in years, a handful of them. The first great data releases are expected within a year or two, and each one will either contain a moving speck at magnitude 25 or tighten the noose of absence a little further. Some night, quite possibly a night when you are lying exactly where you are lying now, a piece of software in Chile will flag a slow-moving object in a crowded starfield, and a human being will be paged to look at it, and they will check its motion against a 10-year-old prediction, and their heart will do what Einstein's heart did in 1915, or that night will simply never come. And by the early 2030s, the silence itself will have become the discovery. There is no third option anymore. That is what changed this year. The question your grandparents' could have asked, and did ask, under the same sky, is finally, actually, about to be answered. Allow yourself for a moment to imagine the morning it happens. Not the science fiction version, the real, procedural, human version. It would start quietly, the way these things actually start. A candidate flagged by software, checked against archival frames, found again the next clear night, and the next, its arc slowly betraying an orbit measured in hundreds of Earth-Sun distances. A handful of people on Earth would know for days, maybe weeks, sworn to a careful silence while the confirmation images accumulate, walking around grocery stores and school pickups, carrying the largest secret in the solar system. Then a circulated telegram to the world's observatories, the way astronomy still formally announces such things, and then the flood. You would wake up, reach for your phone, and see it. Every language, every feed, every front page on Earth, the same sentence. A new planet has been discovered in our solar system. Somewhere, a stunned 70-something Mike Brown would be standing in front of cameras, half laughing, the man who subtracted the 9th planet presenting its replacement. Somewhere, whole classrooms of children would be watching their textbooks become historical artifacts in real time. And that night, everywhere on the dark side of the Earth, millions of people who had not looked up in years would step outside and look up toward a point in the winter sky the news had shown them, at a planet they could not see, and feel the solar system grow around them. It last happened 180 years ago, by candlelight and letter. It may happen next before your alarm goes off some ordinary Tuesday. And I love that this whole drama has an address in your own sky. It isn't abstract. The search zone, the strip of heaven where the mathematics says the planet most likely hides, lies in the general direction of the constellations of winter, out toward Orion and Taurus, and the crowded glow where the Milky Way runs behind them. Sedna itself currently drifts through Taurus, far too faint for your eyes, but there, genuinely there, a few finger widths of sky from stars you have known your whole life. Some clear evening, when Orion is up, you can step outside, look toward the hunter and the bull, and know that somewhere behind that familiar scatter of stars, the flock is leaning, the archives are being searched, and a world nobody has ever seen may be hanging, at this exact moment, in the dark between two stars you can name. People have always looked at Orion and felt watched over. It would be very like the universe if, all along, there had been one more thing up there, looking back, too dim to notice, too patient to care. And so we arrive at the end of tonight's journey, with the answer still out there in the dark, which is, if I'm honest, my favorite way for one of these stories to end, because tonight you are living inside the last chapter where nobody knows. Now, as we finally come to the close, let the details soften and keep only the shape of the thing, because underneath the orbits and the arc seconds, tonight was a story about how yingfully the universe keeps its secrets, and how stubbornly we pry. Think of the chain of hands this mystery has passed through. Herschel in a back garden doubling the solar system by accident, Leverrier at his desk, reading an invisible world out of a wobble, then chasing a phantom into the sun's glare for the rest of his life. Tombaugh at his blink comparator, a farm boy checking hundreds of thousands of stars by eye, finding the wrong right answer. Standish quietly erasing a century-old ghost with one corrected number. Brown and Trujillo and Rabinowitz netting Sedna, the car parked on the roadless mountain. Shepard and Trujillo again with the second impossible world and the sentence that lit the fuse. Tugging and Brown setting out to kill the idea and becoming its champions. Fan dusting off 40-year-old archives to find one flickering maybe. And now thousands of engineers and astronomers on a mountaintop in Chile, aiming the largest camera ever built at the oldest, unanswered question in the sun's family. Not one of them could finish the story alone. Every one of them moved it. That is what our species looks like when it is at its best. A relay race run across centuries in the dark toward a finish line no runner is sure exists. And notice what the prize has been all along. Not power, not wealth. The prize is a map with one less blank on it. We are the map-making animal we have always been. We drew the coastlines before we could survive the oceans, charted the far side of the moon before anyone could ride there, and named the dead-end streets of the solar system before we finished counting its worlds. Somewhere out there tonight, either a pale, unnamed planet is sliding through its 20,000th year of silence, waiting for the software in Chile to notice it, or the outer dark is empty and orderly, and we are about to learn, one more time, how easily a pattern can seduce a careful mind. Both endings are worthy. Both endings are coming. And you and I get to be awake or gently asleep while the answer arrives. Thank you for joining me tonight, out past Neptune, out past Sedna, out to the cold edge of the map where the sun is just the brightest star, and the biggest secret in the solar system is still keeping itself. If tonight's journey brought you rest, or gave your thoughts somewhere vast and quiet to wander, a like or a subscribe helps more of these nights get made, and it means more to this small channel than you'd realize. But that's for the morning. Nothing more is asked of you tonight. So let it all go now. The arc seconds, the archives, the odds. Keep only this. Above your roof, past the rain and the clouds and the familiar stars, the solar system is bigger than the poster on any classroom wall, and it is not finished introducing itself. Somewhere in that direction, the flock of frozen worlds is leaning, all together, towards something no one has ever seen. The camera on the mountain is watching now. The long story is almost over, and whatever is out there, planet or phantom or something stranger, it has waited 4 billion years for its name. It can wait one more night while you sleep. Sleep well tonight. Good night.